Okay, I think that's hopefully about to go live. Jonathan, yeah, oops, I got the title wrong on the broadcast, did I? I'll change that. I will change that later when I change the title of the thing. Thank you for the heads up. Bit of a rush today, lots of things to do. Okay, so welcome everyone. This is the Saturday afternoon when I promised that I would take a look at getting the debugger running on the machine. So we're hopefully going to be able to do that. For those who are just joining and maybe haven't joined in through the week, just to summarise where we are, we're doing the .jam, which we're going to submit by tomorrow to create a dot command for the Spectrum Next. That will be the one we've picked is to do a microdrive catalog because the interface one does fit on the Spectrum Next and works well. But you do need to have a bit of a fiddle to switch between the hardware internally on the Next because it collides and the microdrive. So it would be nice to have some code that is out there and part of the distribution that shows people how to do a little bit more with them. So we're gonna through the week we've developed this .mcat command that is gonna take us into the context. We're working in ESX-DOS at the moment, only because it's easier to do the context switching, or so I thought. We shall see in a minute, because I did have 5 minutes earlier to make sure I had the bits we needed to start today. So the idea is that we've developed in that this mcat command allows us to initialize the variables, which it turns out we don't really need to do. We can do it every time. And we can also then use that to flick back and forth. And we got a little program on the microdrive that allows us to go back to ESX-DOS. So we can basically already use, it's got a use. But the idea is the catalog command will do the context switch, catalog the microdrive, and then come back to ESX-DOS. And in theory, we've not tried this yet because we haven't got a working command that returns. When we come back into the machine, we should be working in NextZXOS as well, because the MCAT will change. I had a little think earlier today that as long as we set up the page and the ROM number correctly, we'll have the 48K ROM in position, just as if it was a standard 128K machine or a +3. And we probably need a little bit of a history lesson as well for what we're about to do, because basically the Spectrum Next is a derivation of the entire line. So of course the +3 software, for those who don't know, the Next obviously is NextZXOS is written by Gary Lancaster, who has this page on World of Spectrum, which is ZX +3E, because the 3 ROMs are something you can add into the +3, which will allow you to use things like hard drives, things like that, and there's a couple of different versions. So really it's been this continuous evolving of the operating system of the Spectrum since it was first launched, and the Next represents, on NextZXOS represents the very latest version of that, obviously. So hidden on this page, which you may not know, is if you do want to see anything about some of the commands, a lot of them, the differences to NextZXOS are in the documentation, but some of the underlying stuff is also applicable from here. So like +3, the +3 commands and things like that, they're useful. But there's an additional software downloads page here, and there's a couple of useful things. Obviously ZXZVM is included with the release, the current one, but there's a little bit about the code machine debugger as well. That is quite a handy little program that allows you to, as I said, the picturesque code machine monitor, which allows you to debug, and that's what we're really going to need to sort out this stack switching problem that we've got, because we really don't know what's going on. So the easiest way is going to be to step through the code and see what's happening. Now what Gary's done in the past, because he's had this problem, because he works with ROM switching a lot, obviously that's primarily how it's all done, he's patched the picturesque code machine monitor so that it doesn't rely on any ROM routines, even including for characters and things like that. So it's pretty much independent of all the ROMs. So I have played with this in the past. It's been a long time since I've done anything with it, maybe like 3 or 4 years. So bear with me if my memory's a little bit weak on how it all works and set up. So that's why I thought I'd run the little session now, is getting this organised and show you how it's done, so that if you want to go and do this yourself, you can. It's a handy little memory resident debugger. You've got the NMI menu on the Spectrum Next, which allows to do a heck of a lot, to be honest, and pretty much means this is less necessary. But certainly if you're working in ESX-DOS, it's handy having a proper monitor that you can do. There is one you can get that loads into ESX-DOS's NMI menu as well. But there we go. I'd quite like this, because you know where you're putting it. You can set it to be at any address in memory, so you can work around your memory map. And that might be something we explore, is everyone understanding what the memory map is that we're dealing with, so that we can follow through on what we're doing. So that's the task now, is to get this picturesque monitor running on the Next, so that we can then load in our MCAT command and debug why it doesn't always work to switch back and forth properly. And then we can take what we did painfully yesterday, which was to type in all the extended microdrive catalog commands from the thanks very much to Ped and Hank and everyone's support for spotting code errors. But we've now got that assembling under Z80 ASM as well. And to pick up on the other thing Jonathan asked about, the link to my public GitHub, yeah, I will push that out. At the moment, it hasn't got any code there for the loadable drivers, but like I said, is the main TB Blue GitHub in the source directory has got the current .command source in it, which is just about usable. It's probably not really ready for branch, as I was ticked off about. So we'll hopefully it'll be working by tomorrow night. So it's only 24 hours. It's not a working release. But what I'll do is I will release a more rounded set of bits and pieces onto my GitHub, and try and put some links into maybe this video of the things that have come up over the last couple of days. Simple things like Hank's code for the he's got quite a bit with the shadow ROM and that and the assembly for that, and he's also done a working version of the MCAT that works under a different assembler, so they're handy to have. Hi Peter, you alright? You still enjoying yourself in Cancun? Have you seen any more what was it that was running around? Some sort of thing on the I saw in your photo. Alright for some people, in it. It's lovely and sunny here in Wales, though. It's been hot. I got my shorts on, so my no shorts for March is now wearing shorts for June. So can't complain. Took a little trip on the beach earlier and had a little look out over the seagulls swooping for their sarnies. So not quite the same, but pleasant enough to get a bit of fresh air and out and about. So hopefully, I didn't get a lot of sleep last night, I have to be honest. It was late finish with the coding. It was a bit of a mammoth session, that, but we were determined to get MCAT working. I was quite surprised so many people stuck it out so long. Right. So let's take that, and then just to finish up on the summary for those who are picking up on replay and are joining later. The idea is to take that extended MCAT command then and stitch it into our simple cat that we're trying to do once it's working. Well, I won't complicate it at the moment. That's tomorrow. My thinking is I'll probably stitch the two together, and we'll have an extended catalog that is part of MCAT. So NextZXOS should be able to load it into the .command area. That'll set up the right page and the right ROM. It'll pivot into the context of having a 48K ROM and the shadow ROM available. It'll use the shadow ROM services to set up a stream in its variables as needed. Do the catalog into the space in the stream that it needs. Then it will. Before that, of course, it has to copy the code somewhere stable, because we'll lose the RAM in the where the .command is, so it goes up in it. Oh dear, on the beach, eh? So it's okay. I'm sure it's just the same as Barry Island. Never been there, but I'm sure it's really nice. So That must be an ultimate heaven, really, to be sat on a Cancun beach with probably easy access to beer and plenty of nice views and hot weather, and be able to watch your hobby unfolding in front of you thousands of miles away as well. The miracle of modern technology, eh? So little could we have thought when we had those 48K Spectrums come out the box and go, oh, wow, oh, look at all this and colour and everything, that one day we'd have something that's 10,000 times as powerful sat in our hands. Watching some bald guy 40 years later trying to explain how the system worked 40 years ago and has no idea how the modern one does. You've been there. Oh, well, here we are. So you do mean it's exactly the same as Cancun then, Peter. Right, I'm getting distracted. I was warned not to watch them, but it's nice to have the interaction. That's part of why we're doing this, isn't it? So, okay, where am I? In terms of the code and machine code monitor, if we go to the desktop, hopefully, can you see that screen? Yeah. Might be easier with this one. So the idea is from the instructions that he has got basically the code machine is not a relocatable monitor in the strictest sense. It's got a bit of code that sets it up at a particular address. So when it's run, when you first run it, it does all the setup of the 48K the monitor into its renumber any addresses for where it's going to run, so you can actually put it anywhere you like. So he gives instructions on how to add his. You load the machine out. You load your code at this patch position. You then do the randomize, which activates the patches. I think that's because the code is 6097 bytes long, and that makes it an extra 1526 bytes long, so it's about 7k of space needed for the program. And then once you've done that, you should be able to then start the program. Now on the this machine, I think I have some stuff I've done before, which is the code machine. So if I do a load star cm31.bas, it'll try and auto run and say no such drive, because of course it's meant for a Resi DOS install. So it just does a clear 3999. Let's do it big screen so you can see what I'm talking about. It does a clear 3999. Loads in the CM31 original code, which has already been patched by Gary in this one. So this is the one that's on the site that's ready done at 40,000. Then in theory, this poke he's doing here is something he picks up on the site that says that he's found out about hook codes being triggered, and this is supposed to fix it, where he patches 42530 with 24, and then you do the randomized user should start it. So if we change the load on the machine to a star, so it loads from ESX-DOS, then in theory, when we run, we should end up in a picturesque monitor. 50 out of memory. Okay. Let's do a load. Edit that and go in and start and then run. Out of memory. Why are we getting out of memory? What have I done wrong there? Let's reset the machine. CM31.bas. Oh, and this is the problem I had, for those who haven't spotted. For some reason, when you do that, you end up in TR-DOS version 5.04. Now, I can assure you, that I do not have one of them plugged into the back of this Spectrum. All right, it isn't actually got a beta disc in the back of it. So I don't know. Well, I had a little bit of a scratch in my head why this was happening, but of course ESX-DOS, which I've installed on the drive, doesn't come with the Next, has actually got a compatibility layer for TR-DOS 5.04 in it, so it can load a lot of the Eastern European programs that are stored in this format, because for those who don't know the background, TR-DOS and the beta disk format became incredibly popular in Eastern Europe, who were using Spectrums long after they sort of faded into the past in Western nations. And they built out quite a lot of this, and there's a massive amount of available software in a particular format, and ESX-DOS can load those. So by doing this, by basically having the DOS in there, and it's sort of semi-compatible with the hardware, so I think it's been patched to work that way. That's part of the reason, because of the licensing situation. It doesn't actually come installed, but it is very quick and easy to install on onto the Next if you want to have ESX-DOS on you. So I think what's happening is that there's something to do with these hook code things with the interface 1, and it's accidentally triggering that, because of course I think it uses hook codes for TR-DOS, pretty much the same as the interface 1. So that was about as far as I got, because like I say, this particular configuration with interface 1 and the latest version of ESX-DOS, I haven't used the picturesque this debugger on here since I can't remember when, long time ago, and that was definitely didn't have the interface 1 connected to the Next and things like that. Was when I was first developing Paul back in 2017 to go on the Next. So I think there's obviously something's happened since that's made this trip happen. So it has a bit of new discovery for us. But I think what I might be able to do as a first step to work around it is to actually use our switching into the interface 1 and 48K basic context, disabling the ESX-DOS, and that should allow the picturesque monitor to work. So I'm hoping I'm going to do a version of that basic that uses the our MCAT context to actually move forward. We'll have to do it in 2 hours, but that's my hope anyway. So I'm going to reset the machine, and I'm hoping I can do a load star cm31.bas. Right, now I will I am going to, at 45, I'm going to do a .mcat-i, which will take us into the context of doing the interface 1 and disable everything. Now, I don't think because it doesn't, MCAT doesn't actually return, because that's the bug. It won't actually run the randomized user 40,000. I think it gets an error, so I don't think it will go into the picturesque debugger. If it does, we may have know what we're doing. So the thinking here is, so if I do let's do a save here of cm31 m.bas. I'll make it auto. I won't make it auto run for the moment. Okay, so I should be able to reload that afterwards. So let's give it a run and see what happens. Ta-da. I'll put a big screen so we can see what it does. Right, okay. So now we probably haven't got the code at 40,000, but we may have. It may have survived. I better check that the cat works. Yes, it does. So I heard the little bleep then. So we're definitely into the microdrive configuration, but it did a full reset rather than a. But I don't know whether it will have cleared memory probably. So this will crash. Yes, it does definitely. Okay. So I think we will have to do that in 2 stages. So we will load star. For those who haven't seen a reload of ESX-DOS, maybe I can do that. You reckon? Okay, this is the SX-DOS loading. Jonathan, why do you think it's failing on the clear 39999? I don't know why that would stop, because the MCAT does actually work. If we just do this, I think it may be this, maybe having a different effect now, because MCAT-I takes us into the next with a full reset. That's funny. It didn't used to do that. It used to do it properly. But if I run and go back, okay, and do an MCAT 1. Okay, the -I does do the full reset. That's actually how the MCAT works. I forgot that, sorry. It doesn't, the after an initialize, it does do that. So we need, I've done the program wrong. So like I didn't auto run it. So are we in the directory? No, not yet. So I got to run that code again to go back. Forgot how my own dot command works. Oop. Now we've corrupted memory, I think. So let's do a reset of that quickly. Ooh, that's not good. Reset is completely not working. Even holding it in for a long time. Oh, there we go. That worked. Okay. Right, so let's do this very carefully then. Let's modify that bit of basic first. So if I do load star cm31.bas, not cm31m.bas, which will auto run. No such file or directory. We're definitely struggling here, aren't we? Let's turn the machine off physically. What have I done to my copy of ESX-DOS? Okay, I've turned the machine back on now. I will boot from internal card. Thanks, Peter. Enjoy the match. Good luck. I'm not reading out these comments from Peter Jesse's off to watch a Scotland game as much as I was, because watching about 2 days ago of catch-ups, the comments are live. So it seems to be after a YouTube live transmission, it takes a little while before the live chat replay happens. So watch what you say in the chat, guys, because it probably is being recorded and attached to the code. All right, so let's get back to, so we know a working environment. We are where we are. I just make sure I got an LS here now, and there's nothing in it. Are we? No such file or directory. It's like there's nothing in the catalog. Let's do a ESX-DOS itself is not loading by the looks of it. Oh dear, have I damaged my CD card? Have I damaged my oop? Right. I'm not exactly sure what is going on here. For some reason, my copy of ESX-DOS is not working, and I don't know why. I think it's this blooming silly microdrive cable again, is meaning that the machine's not in a consistent state. It's the only one I got as well, because my other one's with Jim. Right. Let's give it one more go. I'm on. I'm going to boot from my onboard card. Let me just go into NextZXOS and check it's all alright. Okay. So seems to be the card is there. Yep, it's all there. Let's just check that the ASM directory exists. Yeah, and code machine exists, and there's our CM31. But CM31M is not there for some reason. Don't know why. I thought that was where I put it. Or did I save it in the top level directory? Because it's all sorted now as well. So CO, CM. Nope. Wonder where we saved that program then from ESX-DOS. I was working for those in the ASM directory, and I'm sure it was in here. Strange. Right. This is exactly why I wanted to do it in two parts. Okay. Let's see if we can get back into NextZX or insert ESX-DOS. Do a hard reset and go back into the 48K. Make sure div MMC ROM and div. I mean, obviously, every time we change context, my capture card goes. So I'm just looking in the Spectrum Next configuration to make sure that the div MMC ROM and hardware are enabled, which they are. So in theory, when I boot into 48K mode now, it should be a standard 48K Spectrum with ESX-DOS. So it's just rebooting now. I won't recapture until we're actually in there. There we are. I've just seen the ESX-DOS boot screen now. So that's looking more promising. So there we go. That's back working. Don't know what we did. .cd ASM .ls cd that cm31.m.bas did not get saved, did it? Let's do a merge then, so we don't actually run that clear, in case it's causing some problem. Merge, don't use merge very often. It's one of those commands that you can't see until you look at it. Sorry. My eyes are getting too old to see these things these days. There we go. It was their merge star cm31.bas. Cool. Right, okay. So if I now edit that and put a star in there, and then we do a save star, actually, yeah. Save star. Let's just make sure it works to save it a copy. We maybe had a problem. Oh, I think I know what's happened. Oh dear. 31 m.bas quote. I didn't actually check it had saved before, did I? And it's not saving. I think this is a problem you get in ESX-DOS. You don't know that your Wi-Fi card has gone into a silent mode, and it's gone into read-only mode because it's been handled and connected over the. I've got a connection to it here. I did have there. So I think the problem is it's not being handled here. Okay, so I don't think then that that's going to be an easy one, but we should be able to do, if I do a 45 stop, oop, and then we should be able to do, if I do run there, and then I should be able to do an MCAT1, which will move us into the microdrive context with an error. But we are at least in the microdrive context now. Then I should be able to do the go to 50, and that should get us into picturesque now, hopefully. Nope. Interesting. Not sure why that's doing that. Wow, the sun's really coming through the back yet. So I'm gonna draw the. Shane Peter's already gone. He would have seen my t-shirt. So I'm sure he'd been pleased. Alba. Okay. There we are. If you're watching on a playback, mate, welcome Celtic Nations. Right. Now I'm at a bit of a loss because I don't know. I'm assuming we've broken something, but I need to get into the picturesque command line. So I need to get into that monitor. I don't know why that is busting. Sorry, the machines. Let me turn my phone down. It's going bleep because people are messaging on topics that are related. Okay, I should bleep less. Hopefully, they'll turn it down a little bit. Yeah, there you go. Need to do a bit of thinking now, don't I? What's gone wrong? I really don't know. Like, these are the ones I've worked on previously, obviously, where I've had where I've had the machine set up. But I'm fairly certain the reason it's not saving is because of this. My Wi-Fi card has gone into read-only mode, and you don't get any errors on the on the SX-DOS. It doesn't show. NextEdXOS can tell you that it's gone into read-only mode. Oh, there's a CM31M bash, you know. Where did that come from? Oh, we just saved it, didn't we? Of course. Right, so load star. Because I turned the machine off, which resets the card. Right. So I'm not sure why that doesn't actually just work. And we know this code works reliably because I've done it many times in the past. So I wonder if it's because of the error in the microdrive context. So what we could try doing is, if I put the 45 stop in there again, run it again. Oop. That wasn't healthy, was it? No. Run. Okay, that's better. Now in theory, how can I get into microdrive mode without setting that? Now I need to do it all the right way, then I need to go from a sequence completely. So I need to do the concat -I, which does the reset. I need to go back to microdrive, back into the other mode correctly. I also need to find my notes from the other day, because I can't remember. Oh, they'd be on the back of there, aren't they? Yep. So and I'm 99% certain this is just the crappy microdrive cable where I'm having to get at the because that ran and took us back into there. So now we can do an MCAT2 and we can do a CAT1 again. So we can flick back and forth between microdrive and ESXDOS hopefully. Yeah, and I can run the code to go back to ESXDOS and I am in the right place. Yeah, and I can then load star quote cm31 m.bas and I can put my stop in and I can run that, which has now got a patched copy of it all in memory, and I should be able to do a .mcat one, which will take us back in quietly. Although I could, rather than doing that because it gives an error, I could just turn the bus off, which of course is my function key F6. So hold on NMI and do that. And now the cat should look at our microdrive. No, it hasn't. I want the bus on, sorry, so it's NMI in 5. And I can then do a CAT1, hopefully. And it's crashed. Blast. Don't we love inconsistent handling of stuff? This has been working all week, every night. You'll see why we want to get these MCAT and .microdrive commands running. Okay. That definitely sets up the disable enable stuff. And I should just be able to do a cat on the, yeah, which can. And then I should be able to do an enable of the bus with Control F5. And press the NMI yellow button and 5. It is off. So F5 is on, and that should now allow a .ls to work. I thought, didn't I not do it hard enough? That did work the other day, definitely. Oh, bus off I need, F6 to go back to it. And that should, yes, there we go. Pressing the wrong button, because I wanted to turn the bus off to disable the microdrive. There we go then. So we're able to now move between the two contexts with the function commands. So I should be able to load cm31 m.bas and I put my stop in. I should be able to run that. I should be able to do a control to turn the bus back on again, which is NMI in 5. And now I should be in the microdrive again. Yep. Once we've worked out the sequence, it'll be dead easy to flick back and forth. Can you? Oh, sorry, mate. That's me not keeping an eye on it. Okay. There we go. So that's just in a catalogue. I've just done this program. So I've pressed the... Basically, I've loaded this from ESXDOS, done the function key and flick back with the stop command in there. So when the stop command happened, I did a function key to end up as on a interface 1 available. So I'm now thinking we should be ready to go to 50, and that should start our picture monitor. Oh, that got further than last time. That was a pretty spectacular crash. So, but we are getting closer. So I think what we're going to have to do as a task is prove this works without the interface 1 ROM on it, so that we know the picture S monitor's working. And it might well be that Gary's thing about the problem with the interface 1 is related. So what I'm going to do then, I'll leave that so we can see. This is not a bad... if it's clear enough, you'd be able to see what I'm doing with that. This is probably an easy one, because as I flick back and forward, it does reset. So what I'm going to do, I'm going to power the Next off completely, unplug the HDMI so I don't end up with any back power. I am going to unplug the interface 1, which is tough as heck on a Next. Ooh, there we go, it's gone. So now I am going to turn the Next back on. And I am going to power it up again, and then I will plug the when it comes on, I will plug the card back in, the HDMI. Okay, there we go. Right, now let's just prove that my theory is right about that being able to run the micro drive of the Picture S monitor. So we're going to now do a CD into ASM, a CD into Code Machine. We are going to then do a load start cm31m.pass, which should be ready to go. And when then we do a run, I'm not going to switch into interface 1 mode because there is no interface 1. This should just run the picturesque on the Next, and it doesn't. Excellent. I know it seems terrible, but that's a good sign. That means we've been fighting a losing battle because it doesn't actually work. So now I got a feeling that if I go back up a level, I got a feeling that that is on here in the top level direct. I got a lot of junk on my card. It's obviously do a lot of bits and pieces, but there should be a CM41, and I think that is Code Machine at 41,000. That's the one I used to use when I'm debugging myself, because I've done a complete patch set and saved it off of 41,000. So if I do a clear 39999 and a load start CM41 quote code, and then I do a randomize user 41000, press break for monitor, and that's a working copy at 41k. So let's try getting this to work with the interface 1, and then we maybe need to go back to re-download from Gary's site at another time. I wouldn't mind actually if somebody else fancies playing with this, trying it on their Next and following Gary's instructions. Maybe there's a maybe something's changed, but this definitely works, so I don't know why. I'm not completely convinced as well. His ready patched one, I ever tried it, thinking about it. I think I just downloaded the patch because I couldn't use it at 40,000 because that actually collides with where port is. So I think when I did it, I actually downloaded it myself, patched it myself, and then ran it, and put it at 41,000. I did the relocation instructions and put it at 41,000 and saved it all off. So I'm suspecting that's the problem. I think maybe that there is a bug in that ready done one of Gary's, maybe just something in error, either my copy not downloaded. So anyone who's doing it, treat it with a bit of respect, and actually looking at this code, if we do the here, probably download the, take the picac.tzx, completely do the patches as needed, and put it, especially if you're playing with interface 1, put his poke to disable the problem with the trying to detect the interface 1 ROM, and then do it your own. Now I don't know whether I've made that poke on my copy of PictureX, so if this crashes, because if I just quickly check on the Next itself with an M, and we just look at 0000, and obviously we can look through the memory on the Next quite happily. So let's go back again. I'm going to turn the power off again. I am going to disconnect my HDMI because, as you know, that the Next doesn't fully reset otherwise. And get my interface 1 refitted. Make sure it's in properly and the cables haven't been disturbed. Then I'm going to power back up the Next and boot it from its onboard card. And then as soon as we got a display that's usable, that isn't going to change the framing. If I can find the HDMI port, blind. Let's down to further down, there we go. So hopefully we've recovered the Spectrum, there we go. Right, so I'm going to do a clear 3999. I could actually do 39, whatever I could do. If it's a 40,000, I could do, I could do 40,9999 actually, which I might do. Okay, I just realised I've actually got an open window on my computer as well. That's what's bleeping, making the incoming messages. But it's good news, we got numbers on the lottery draw. So someone tell me what the numbers are if they get drawn while I'm on a stream, because I might just stop it instantly and go and join Peter in Cancun. Then again, that's unlikely to happen, so you never know. Okay, I've done the clear. I should be able to just load that CM41 code at obviously it'll load at 41,000, and I should be able to randomize user 41,000. Press wait for monitor, works fine. Okay, so it looks like there may be a problem with the CM31 BAS and the ready patched C code that Gary gives on his thing. I'll maybe someone else needs to have a little play with that and make sure that I'm right, and we report it to Gary, because I'll try and find out for him what's wrong with one of you. That'd be great. But we can at least get into a monitor now. You can see why that's taken an hour just to get to the thing I knew used to work, because I've tried to show people how to do it from scratch again. And I've used the PictureX monitor quite extensively for debugging before we had any tools on the Next at all. Okay. So let's see if we can jump into the interface 1 context as well with doing that. I can't remember how we get back out of this. Is it Q or B for basic? I can't remember. No, B is a breakpoint. X, is it, or something? Return to basic Y, there we go, because it's the return command on the keyboard. There we go, right. So if I now do a .mcat, well, let's just do it with the function key now. So I'll turn the, we've not done that out. That's what, unless we run the mcat, the out doesn't get done. So just quickly, let's do it by hand, what the mcat command is doing. And have I got a .jam? We have got the expansion bus. There we go. So it's this one, the out 135246. So let's do an out 9275 comma 135 colon out 9531 comma 246, which disables the interface, disables the SDI and some of the code that the DSX DOS relies on. So now I should just be able to do a function key and bus off, which is F6, I think. Hold on that and do it 6. That's not working for some reason. Don't know why. If I hold down the NMI menu, 6. Oh, there we go, that did work. Okay, so now I should be in microdrive mode. Oh. Have we still got the picturesque monitor that we have? So if we do a so we disassemble the first bit of ROM. So that's just the disassemble the Z command at address 0. So looking at this, this is the standard 48K ROM. So as I'd expect. So why am I not being able to do a microdrive catalog? Okay, let's see if it's still a code has survived, and we can do a cat now. Yeah, I must have missed something. So just check I can catalog the microdrive. Okay, which I can. And let's just check that my program code still exists, my debugger code still exists. It does indeed. Okay, right. We are at least in a possibility that we can run the mcat commands, flip back and forth context, and get into the debugger. This is turning into a harder job than I thought. This really is. I thought I could knock this out in a few hours. Okay. So now we're in a position where we've actually got a monitor that runs on the machine, which is what I wanted to do. So that's not bad. What I think we'll do is I'll carry on now, having a little go at seeing if we can get the mcat command as the subject of the debugger. Because that will be, if we could find what's the problem with the stack and the imbalance, that because at the moment I think it works through luck, ending up with that error, with the IO error when it jumps. So we really do need it to be more reliable for what it's doing, and why it doesn't go back. And we had that with the other bit of code that we've got the problem with is the one that's based on POR. So our MCAT works, we know it does it, context switching, but we still know we need to get the code copied in memory. Now the code we're planning on running because .mcat is only a context switcher at the moment. All it does is flip back and forth, doing the disables and enables of the ports and the resets. But the plan is it will copy up the catalog command. Now, like I said last night, we got the extended catalog command running fine, which means good, we can catalog a microdrive in full detail. But what we didn't, the bug is in the initial catalog command we did, which is based on the poor microdrive drivers. So hopefully everyone's aware of that. And that's where we've got the bug. So we've got these 3 sections of code: the context switcher, the initial catalog thing that handles the ROM switching and all the interface to the interface 1, which we've stolen from POR. And then we've got this advanced catalog that basically uses that technology, assuming it's all working. And when we stitch the 3 together, we'll get the advanced command. But the problem we got is with the standard catalog command, when we do it, we stick it into memory, we try and run it, it goes bah, and crashes in certain contexts. So I can't remember where we put that code. So let's take a little look at it. And this is the we're going back now to extended catalog is the extended catalog. MCAT is the context switcher, and MCAT main is the assembly language that we're working on. So let's go to full desktop so we can see the assembly language code, and that's a 49152. Now I got a feeling on a page boundary, I think I made sure that the picturesque monitor doesn't touch that page boundary. Let's do some quick calculations. It's basically so the memory map would be it loads at 41,000, and it is 1526 extra, so 6 down 3 carry 1, 10 13 3 down carry 1, so 2, so 7, so it's 7233 bytes long from 41,000, which means it'll run to 48233. So it doesn't get as high as the page switch. I've purposely made sure of that because I'm 99% certain that's why I put it where it was. It was as high as you could put it safely. You could probably put a little bit higher. You could probably put another 500 bytes, and it won't hit the this address here, which is the first address that you get when you switch the 16k banks in the top of memory, which is why we're putting the specsys.asm there, because the longer term plan is this will sit in a bank that we switch in and then switch out. So the MCAT command, when it's first run, will allocate itself a bank, stick the code it needs to run into that usable bank of memory somewhere that's safe up in high memory, and then from then on, I mean, longer term, I suppose that we'll have a suite of dot commands was the idea that, you know, you'll run an MCAT -i and it'll do all that for you and hide its code on a bank away from it, and from then on you'll just be able to use the commands without having to do it, and it'll just all be hunky-dory, and we'll be able to use that bank as a buffer, for example, for copying files. So okay, right, so in theory now we should be able to load our, as far as we've got with our specsys.asm, we should be able to load the specsys program from the dot directory and our monitor program, and that should allow us to be able to go into the monitor in the context of microdrive and trace what happens when we call this code. So I'm going to do that next. That's going to be the next thing I have a crack at. Okay, let's go then. Let's give you the next screen again so we know what we're doing. I'm going to return back to the basic, and we should be able to, if I can use the function key to flick back to the code, so I'm going to put the bus on, which is F5, so NMI held down and the 5 key, and that doesn't seem to work. Don't know why that's doing that. Okay, does a few. Funny. Okay, so I've pressed the F5, and now I should be back in ESX-DOS. Nope. Am I still? Yeah, I'm still in the microdrive one. Oh, it's because F6 is off. Ignore what I say. Don't do what I do. Okay, so, and 6. It just doesn't like this NMI being held down. Okay, that's funny. Hopefully less soon that's done it. Yes, it has. Yeah, it's a bit fiddly, that F key. Right. What are we doing? We need to probably, I'll put all the files in the, I'm going to bring up the the directory, and then we'll stick all the stuff we're working on into the same directory. So if I take, I'm going to take a copy of my CM41 program, which is the code, and we'll stick it in where we're working, which is the bin directory. Bit of a mess, but paste, just so I can load all the files from one place when I'm working. Okay, I'll clean up afterwards. Have we got a copy of my program in here, which was called mcat main? So mcat main should be in here. mcat main.bin, yeah. Okay, right. So we're going to go back into the context of showing the next, and we are going to do a .cd into the bin directory, which is where we're working, and then I am going to, I'm 99% certain the clear is still valid because we haven't actually done anything that could affect that. So I should now be able to load star mcat main .bin quote and code 49152, because it won't have a load address associated with it, I don't think, because I've just dumped it as a bin file. So it is code, but it's got no load address associated with it, which is why I have to always put the address on it. Okay, so now if I go into our monitor, 40,000, so within there, I should now be able to go back to the, you probably do need to see both screens for this, because you're going to be able to, you're going to want to be able to see the code as well. So let's bring that up. And in fact, we probably want to be able to see the listing of the code that's successfully loaded, rather than the, if I got a copy, there we go. Okay, so now we're actually looking at the assembled code. So as we step in through, we'll be able to see the actual things that are happening. So if I now go to I'm going to have to move into an area. I don't want to start up automatically. Before I jump to an address, let's just make sure we got the stuff at that address. So that is 8,000, is it? Yeah, 8,000 hex, is it? No, it didn't. And where we put it? 4915. That's A000, isn't it? Isn't it? C. What am I doing? Hex in paging is at C0000. Ignore me. Final, last try. There you go. Right. So call. So we have got CD C1B0 being called here. So it is actually, we're looking at the right bit of code. Excellent. So what I want to do now is I probably, because it is a single step option on it, I can't remember how to do it. Move, jump to address, set a breakpoint, restore codes display, continue operation, return next jump, disassemble, trace, a single step the front panel display. That's it, T. So if I do a T at C000, okay, so this is a single step call. When you're in the single stepping mode, there is a bit that you've got to fiddle with, which I can never remember how to do it. It allows you to go, it's to step over, to make the call to the subdirectory, but not to the subroutine, and not actually trace it. Trace or single step, blah. You would have thought muscle memory would have taken over for this, wouldn't you? But I just can't remember it. Sorry. Message from somebody. Right, there we go. Okay, so on the T1 for tracing it then, you can, right, the commands on the trace monitor are any section of code, only operate, run at full speed. Yeah, it's quite a bit that won't work, so they haven't got just a summary of the commands in trace mode in this book. So because we can execute the one command, we can jump into the subroutine, but there is definitely a way of doing a skip over, because I know that init ROM code works, so I don't really want to go messing about with that. Oh, thanks, Hank. So HiSoft catalog, one reference with the label cat directly to the shadow ROM, which differs between the two. Okay, so we need to patch, when I patch that in, make a note of that. When we patch the HiSoft code into this code, we should modify that one shadow ROM fixed. And that's this code that we're just about to jump into, the init ROM with picturesque, that will do it. If I can remember how to use the picturesque monitor. You've got to skip to ret, which is once you're in the subroutine, it'll run everything down to the next return instruction. Okay, well, I can use skip to ret, I suppose, because we can just watch it run. So if I let the call happen, so we'll end up at C1B000, and then we'll just do the skip to ret maybe. So I think if you press R now, it'll skip to ret, which basically means we're going to run the initialization code automatically, which is down here, and this is the bit that, as Hank says, we've got to modify to patch the other code. So we need to add a new bit in there to patch the other address in the code when we put there. So we will do that. Let's turn on, I think code highlighting still works even in a list if we do it. So view highlight mode Z88 I think will work for us, which should make it easier to read the code. There you go. It looks a bit cruddy with the hex numbers and things, but at least it's easy to read the code. So we're basically now going to let that, going to wait until we get back to here by letting it run init ROM, by basically doing the R. So I'm going to R, and we go and press enter. So skip to ret should run. Right, so it doesn't actually run until you press enter the second time. So here we go. So we're now at a halt in 1303 somewhere. I know why, because we've actually gone into the shadow ROM at 1303. Because of course it's a lot of stuff. That's why I wanted to skip over. Because we're going to have to go through the entire set of the machinery now. Well, it keeps going and keeps going and keeps going. Yeah, because all we've done now is we've ended up going all the way down to here, and we've just, I think, ended up in this RST8 somewhere where there's a halt for some reason to do a sync. So I think the best bet might be just to let the code run. If I do let's get out of the single step in mode. We can get out of it, I think. I think we can go back with X. Yeah, I'm gonna disassemble the C000, not the printer. And what I'm going to do, I'm going to put a breakpoint on C003, and then we will just continue the code from where we were. So we just put a breakpoint when it's done the init, basically. So what we need to do is probably look at the stack pointer. We probably need to start this from scratch, look at the stack pointer, see what's on the stack, to know the state we're in when we get into basic. So what the stack pointer pointing out and where it is, because we're in a bit of an indeterminate state now as I started to run. I'd forgotten about that, where this can end up into multiple subroutines. I just thought it was a bit of code that ran, but it doesn't. It does quite a bit of paging and things, so should have paid more attention. So I'm hopeful. I wonder whether I just can you let the code carry on from the skip to ret? Can we just continue and allow it to finish? But we know that's going to end up with a bug anyway, isn't it? So it doesn't really matter. Let's put a breakpoint then at C003 just to prove we can do it. Which is we need to put it at C003, and then we can hopefully how can we continue the code? We can breakpoint continue. Will that continue from where we are? Nope. Okay, like I said, we ended up in a bit of an indeterminate state there, so let's just let it do a catalog and prove it works. Nah, it's crashed. See if our code survived. Nope. We've got a bit of damaged memory there. So we're going to have to... I think what it'd be worth doing is writing a bit of code to get us into a known position. So I'm going to do a little program which will do clear for... We might as well stick with it. We can do 4.1, can we? 4.1, 41,000 I got at, so 40999, 20, load, star, CM41, code, CM41, semicolon, put quotes in, code. I don't need to give it the address because it's saved from with a load address as a code block, and then I want to load our cat main.bin quotes code 49152, and then I want to do a 40 randomize user 41,000. Did I say 40,000? That's probably what crashed it. Randomize user 41,000, which will start our thing. So the program, the debugger. So I'll just save that as a just a program called T. So it's quick and easy to load. And let's just check that that ended up on the drive. Nope, it didn't. Why did I not end up with a T program? Did I drop some stuff on it from here? I may have gone into read-only mode again if I've dropped anything on here. Now in NextZXOS you can just remount the card, but I haven't got a remount program in NextZXOS in ESXDOS. No, it definitely didn't save the T program, did it? Nope. Try one more time. Nope. That's a shame. I'll have to do that from scratch. I'll write a copy. We'll start the machine up, not in write only mode, and I'll do a quick one to keep it going. But it's just to prove that works. Yeah, break. I'm going to put a breakpoint at breakpoint at C0003, and then we're going to do a jump to C. Is it J? Jump to C000. And I can't see the stack when I do that. That's because I'm in ESXDOS, isn't I? Silly boy. I still got ESXDOS running. Oh, what an idiot. Right, let's do this all from scratch then, so that we can turn it off, unplug the HDMI, turn it on, which will ensure that the flash card is now not in read-only mode. Power it up. Okay, so we're now ready to go with that program. Let's get that program done. So I will cd to our bin directory. I'll do a 10 clear 40999, and then we'll load star CM41 into its designated code address because it is at 41,000. Oop. 20 maybe. Load star. I actually did load it then. CM41 code 30. We're going to load star mcat main dot bin, and we got to fix it at 49152. And then we've got to do a 40 randomize user 41,000. And now I'm going to save star T, which should save this down. So if I do a 5 to refresh that directory, we should have a T. There we go. We've definitely got it now. Excellent. Right. So I'm going to run that. That isn't going to help us, is it? Because we need to be able to switch into MCAT-I mode first. So let's do an MCAT. Something definitely needs to be done with that first, which it does. And then we go back to ESXDOS, which we know works. This context switch method works. Now we should be able to load star T. And then now we've already got that, we do need to be into microdrive mode before we run it. So we want at 35, we need that .mcat mcat1 command, which will jump us into the microdrive mode. I don't know, you can't run dot commands, can you, from ESX-DOS basic? I can't remember. Can you? I'll have a look, see what happens. Yeah, you can, okay. Now, of course, it doesn't return because we've got this context switch bug. Oh, because we've got it working by luck because it isn't actually in high memory. So if I go to 40, let's just check we're actually in the microdrive. Yeah, we are. Yeah, it was, for those who, if you watch the first one, there's a bit of a fluke that mcat-i happens to be at an address that will return a proper error, so it comes back to basic correctly. So I should now be able to go to 40. In fact, let's prove that the catalog happens as we expect. Randomize user 49152, which should be drive 3 and give us an error, which it does. Okay. And if I do it again, does we get the same effect? Because it does seem to be... No. It's there's definitely a problem with it. So... Yeah, the basic's corrupt because we got that statement lost after the randomized user, which is because of the stack imbalance. Because the machine, that's the bug we're trying to find, basically, it's leaving it in an indeterminate state. So I should be able to just go back to the ESX-DOS. Load star CM and OT, and then 35.mcat mcat1. I'll keep it consistent because we're doing an mcat3. I'm going to save star T2 just as it's got that in it. Let's prove that we shouldn't be. This should still work. Yeah, it is fine. Okay, so I should be able to run that again now. Okay, and then we can go to 40, which will give us the breakpoint into the monitor. I should be able to set the breakpoint at C003, and I should be able to jump to C000, and I've got great. I've got the breakpoint. So R displays the registers, and what I haven't seen though is, and we need to put the breakpoint at, we need to do the register state when we start the code from basic. So what we need to do is we need to do this in a couple of steps. Actually, we need to go back to basic from the randomized user and see what state we end up in. Because I don't actually know whether that stack position A012 is correct or not, because of course it's the one when we went in the monitor, because we ran it from within the monitor. But actually that's a reasonable statement, because we need to know whether we can come back into the monitor. So if we can get back into the monitor, we can it'll be the same problem because we're starting it from in the monitor. Okay, I think let's sort of just do a little bit of tracing through the code then where we were, because we proved we can get into there. Might as well just have a cycle through this once, and then probably what I'll do, now we've got it all working up, and my purpose for this session was to be able to set us up a usable debugging thing that can be used moving forward, which we've got, and a methodology, and we know how to use it. And then the actual, I'll do a stream later on tonight that actually tries to find the bug. I won't try and find it now because it's coming up 6 o'clock. I'm hungry. I haven't eaten today. So apart from a sarnie and the cheese sarnie, which the girls had half of. So, and I'm going to want a drink and a bit of a rest and recuperation after a long day of enjoying myself. So we'll move a couple of little bits of program now moving forward into single step mode, and follow the code through just to prove it works and see if anything obviously stupid happens as we follow through the code. Right, okay then. So we can go into the trace mode. From where we are at C003. So we should be able to I think enter steps to the next command, is it? So call A028. So that A012 stack, which we copied earlier, that's pretty close to where we are now. So that's above the monitor, because the monitor must have its stack fairly high up. So that probably, yeah, A0, yeah, it's right down, isn't it? Yeah, okay, that's well below the monitor. Yeah, clear 40,000. So I think that's right. That is the basic stack address. Okay, should be below the monitor. So enter should step, I think. So we'll call A028, whatever that is, at C003. It isn't a call. Oh, that's the breakpoint to the monitor. So it's still there. So we need to clear the breakpoint on the monitor. So I need to go back to there. We need to clear after the breakpoint. Yeah. So I need to clear that breakpoint. How do you clear the breakpoint quickly? There must be one. Could do with a command summary, couldn't I? I really thought I'd remember more of this from using it, but break restore K. Okay. So now we can go back into trace, which should be, now that's correct, the load L IX plus OB. Okay, so enter should step that. Load H with IX OC. Okay. And then use our load C with 3, which is the catalog command. So the C register here should change. Yeah. Okay, and then the next to be executed is the load B with IX plus 0E. Now we're going to go into the call C015 because we're actually going to go down to here to the disable interrupt, which we will do. And then we load the contents of the bank register into the A register, which is 0 because we're on page 0. We mask it with a 7. We push that onto the stack, which will drop our stack down to A00E because it moves down in memory, and so the value of that is on the stack. Our IX register, which is O2B7. I have no idea why IX is being preserved here. I don't know what it was function was. Probably hangover from poor. But anyway, that'll end up on the stack now. So we can save the stack pointer into RSP, which is our preservation value of it, and then we're going to load HL with the stack save. Then we're going to save the contents of RSP, which goes into HL, which is A024, and save that into our save position. And then we're going to HL with our underscore error handler, C0BB. So C's COB, that's easy to remember. So COB is the error handler. We're going to push that onto the stack. So our stack is now at A00A. And we know it's got to be back to A012. So where are we? We're doing loading the stack save. We've done push the HL on. We're loading, point the error SP at it. So now we will jump back to here. Set to IY plus 7C. That must be one of the extra variables. So load B with 8, push HL. Okay, this is going to make enough space. It's pushing some space on the stack so that we don't damage anything. Okay, and we load FF ensure no error number. Now call page out. I don't really want to run, I think page out is going to be, it's going to do a jump into the ROM. So I don't really want to do that. I'll try and run it because we'll end up with that problem. Actually, it might be interesting enough to run it in this instance because it can't be that big. That function code dispatcher. We'll run the shadow ROM for a minute, which is coming here to the back address. Load that into it. Then we do the RST8, which now we're in the ROM at address 8, which loads HL with 5C5D that I think we've just loaded. Saves that. Goes to the subroutine of 53. Pops off HL. So it's basically setting up some stuff for the stack. The dispatcher, I think. I'm going to run through it fairly quickly because we know it works. And then it returns, which should take us back to where we were at COB, which is our error handler. Right. So we end up at our error handler at COB. Why have we ended up at our error handler? Now there was a note in this code. Just remember I didn't write this code. So the error handler is always used, even a successful load, say verify. Disables interrupt. So we're running through this code now. Restore the error handler, enable interrupts again. Now, is it a break? Nonsense and basic, always okay. SHUNK. And that does the call microdrive motors off. This is running all over the place, isn't it? It's running all around the ROM doing all sorts of nice stuff. I'm not even going to try and work out what all this is doing. So I think they're looking like it. I'm stuck running the ROM now. Let's go back to there and let's put a breakpoint back into our code. Can we just continue to run from where we were? If I just let it finish, because it should just do that error of the microdrive not found, shouldn't it? Ah, maybe that's what we're doing. We're following the microdrive not found chain, aren't we? If I do a C. Okay, so yeah, we were expecting an error. That's the point. We were following the error route because there was no microdrive in the drive. Right, I've had enough now. I'm gonna go and get something to eat. So hopefully, well, we've had a good run through the code, and we've seen it run through the one route. So we proved we can do it. So we'll do a bit more prep for the next session, and so hopefully we'll see you in the following one, and we can find that stack imbalance in this code, and then tomorrow I can hopefully stitch it all together and make it work as a slick whole instead of running each little bit separately. So thanks for watching, everybody, and if you're on catch up, you should be able to jump to the next episode immediately, because chances are it's already been transmitted, assuming I just don't get bored or have a few beers and decide not to do it. But hopefully I'll schedule one for 9 o'clock, but if I can get on a bit earlier I will, and we'll take a look. I probably will have had a beer or two though, but you know, not a shed full, so it should be a bit more fun for me to debug, and when I've got a fresher mind after some food. So we'll see you all later for a debugging session, and I think we've achieved the goal we set for this particular section, which is to be able to debug ROM switching and context switching even on a machine that's got nothing. So great, see you all later, and we'll look forward to finding the bug in MCAT main. Bye.